sure.
Okay. Hi, everyone. Today, January 9th, 2021. We survived the first week of the new year somehow. And
Awesome.
today, I'm very excited to have our friend Danny, who is incredibly, I don't know what the word is, supportive and helpful and intelligent, hardworking, and amazing presence in our channel. We have this little community where we discuss things and talk about things. And I think, Danny, you are the soul of that little group.
Among other people, as I would say, yeah.
Yeah. So I was really happy when you accepted my invite for this podcast, because I'm really keen on learning more about you, your way of thinking, what you bring. And on purpose, I avoided having any agenda for this. I just want this to be like a clean slate so that we can go in any direction you want. There's no any topic you find exciting at this point. And I'm hoping this is going to be one of the series of our chats, because I know you have a lot to bring to the table. So let's first start by maybe you telling us a little bit more about yourself. And if you're interested, you can ask me about myself. But maybe just tell us quickly what are you up to right now?
Yeah, basically, my name is Deni Amoka, but yeah, my nickname is Deni. Right now, I'm coming from Hungary, but I work in Vienna. I just moved there this year, last year. Yeah, I'm a software engineer, a passionate software engineer. Software engineering is both my passion and my profession. It's really, I really like crafting clean code, using the best practices, best design practices, test-driven development, domain-driven design, and etc. And basically, yeah, my part in the last 4 or 5 years, I've been to Netherlands, and over there I worked for enterprises and corporates, building software for high scaling, and over there I applied these best design practices. I also learned a lot. And yeah, basically that's it shortly. Of course, I can tell always a lot more about myself, but I would say we can start talking about the topics or some other things in more detail.
Okay, thank you. So how did you get in the first place to be so involved and so passionate about software engineering?
Well, to be honest, I'm a civil engineer. And that's my main profession. I wanted to be civil engineer. That was my main goal when I started my university back then. And after that, there was a specialization called geoinformatic engineer, where you can build the digital maps. And I realized, okay, we need to build digital apps, but we were not taught how to build such apps. I mean, how to use programming languages. Really, it was not the main goal of the education. And I realized, okay, but I really love building digital apps, but I don't know how to do software engineering. So maybe it would be really nice to get started with it. And back then, I had a teacher who taught me poker. But he was also a really good software engineer. So maybe I realized, okay, maybe it would be nice to ditch the poker and maybe to learn some software engineering. So I asked him, and he said, okay, yeah, absolutely. He was happy to start teaching me. And I would say the first lesson, I just fell in love with this. I was really excited how I can just make working software or make something from basically nothing, from basically just 1, 2 files put together, and there is a program assembled. So back then, yeah, I started, but still, yeah, I really enjoyed it, but also not clean code and also not the best practices. I just really enjoyed the process. I really enjoyed putting my fingers on the keyboard and flipping zeros and ones, and I just enjoyed it, but still. And after that, yeah, I would say in Netherlands, there was a guy who, yeah, I was for the first company I was involved over there. And yeah, over there we had a legacy code base, but also it was legacy code base. And the people who worked there also were colleagues, because I worked in an agency. But after that, those colleagues had to move to another project. And after that, my managers, my manager put me and also other people in that project. And one of them was really passionate about clean code and these kind of things. And we decided, okay, it's a legacy project. It was not tested. It was really really bad written code with a class with, I don't know, 500 lines and function really not tested at all. And that guy was really passionate, and he said, okay, it's time to refactor. It was also paid. And over there, I really started, the reading the clean code book and watching movies of Robert C. Martins and all the things. And I just fell in love. It was incredible. I worked at that time 40 hours for that company, but in my spare time, I worked, I don't know, 20, 25 hours on my side hustle, side projects. And I realized, oh my God, this is the thing what I really wanted to do. So that's why I started reading books and learning all the things around. And basically, since then, I am unstoppable. I would say I am still really much involved in this. I mean, improving myself and striving for quality and quality software. So since then, I didn't stop. Yeah, there was a time maybe 1.5 years ago when I felt I worked too much. I worked 60 hours, and I felt a little bit borderline burnout. So, but it was not that. Yeah, it was. Obviously it's a borderline one. And I decided, okay, it's time to stop the 60 plus hours per week working style. So I went back to the 45, 50. It's still more than 40, but it's fine. And so since then, I can keep this up. And yeah, I joined to Twitter this year. I met with amazing people, including you, and also many other ones. Really, it's 1 hour wouldn't be enough to mention all of them, how amazing and supportive they are. And yeah, basically, I was challenged by you and other people also in the internet, in Twitter. Basically, it's a global thing, huh? So, and I think also since then, since I started using Twitter, I improved a lot. So it's amazing how much I also improved because, I had to think about it. I have to teach it. Best way to learn something is to teach it. So, and in Twitter, what we do is we teach in some sense, huh? Or we help others teach. And also they ask, and also some people like you challenges us and other great minds. And you have to think, you have to go deeply and figure out the whys. And because it was the most important thing to figure out why we do things, not just doing it blindly, and why we want to apply these techniques, why we want to apply that design pattern, that methodology, etc. So yeah, basically that's it. And now I'm here. I met with you, I don't know, some months ago. We started interacting with each other, and so far it has been a pleasure, I would say. I also learned a lot from you. And yeah, basically, I really look forward to the future and to be more involved. And yeah, no, we have this session, we have this talk, and I wonder where we end up being at. Yeah, basically that's it, shortly in a nutshell.
Thank you. Yeah, so what I'm looking at is a very promising situation where young guys like yourself and all the other people we interact, most of them are youngsters, right?
Yep.
And this is very, very promising and very good because this is like maybe a third generation or second, I'm not sure. Because to me, the first generation where things started changing was 20, 25 years ago time frame when Kent Beck. I mean, I'm talking about early days of extreme programming,
sure.
Which you're familiar
Gotcha.
with. And they were doing some amazing things. And then it's very nice to see young people coming and picking up the torch and carrying it, right? Because as you and I know, it really challenges the way you think, the way you work. And oftentimes it is kind of counterintuitive. Like your first instinct would be like, okay, this makes sense. But then you read something that these guys are teaching and it's completely opposite. And you're like, wow.
Oh, yeah.
And then you're like, I don't believe this. I've been through that as well. Like this doesn't. I don't like. Are these guys serious? Can it really be like things like that?
Yeah,
right?
Yeah.
And so there's always this danger. People say, this is some old school, and I don't, And it's nice to see that people actually are curious and go and say, well, I'm intrigued. What is that? Is it really for sure? And you go and try. And what you did and everybody else. So that's great, right? So instead of just maintaining status quo, right, and saying, well, this is how I do things, I don't care, people go and try. And that is very important, this curiosity. We like to call, sometimes we like to call it beginner's mind, if you know the phrase.
Yeah, sure, absolutely.
Yeah, you know,
Yeah, I
and,
heard.
and this comes from martial arts and
Mm.
Zen,
Oh yeah,
blah,
yeah.
blah, blah. The what we the consequences, for example, of the violence of the Second World War was that we
Mm-hmm.
got in touch with Eastern cultures. Because
Yeah.
Americans bombed Japan, right? So in this horror, the
Oh yeah.
one positive was the learning about martial arts, about Zen, and about this beginner's mind that which was so foreign to us Europeans and North Americans, right?
Mhm.
And
Yeah,
I see a lot of that now with the upcoming forces that you guys are at the drop of a hat. I feel like you're ready to empty your mind of
Mhm.
all preconceived notions and say,
Mhm.
"Wow, this is odd. Let me check it out." Right?
Yeah, sure, yeah,
And that's your
exactly.
strength. This is why I really enjoy interacting with you, because you're always like, "Wow, this doesn't make any sense, Alex. You tickle my fancy. Like I'm gonna go and
Yeah.
check it out and come back and tell you if I agree or disagree." But I really
Oh yeah, sure.
I appreciate that kind of openness,
Yeah.
because I gotta tell you, I'm also working a lot with, I have a lot of experience and years behind me, and you often meet people who are very hardened, who are like, nope, I've been doing this my whole life and it works, and
Oh yeah,
I'm not going to
yeah,
listen about these things. This is all bullshit, and shut up.
yeah. The
And
conservative ones. Yeah.
so that's great, and I'm really happy to see you have a lot of pull. Like you bring like you're bringing these things challenging, and a lot of people jump in and comment.
Oh yeah.
Like this is great, and
Yeah. The engagements and all the details and topics. Yeah, it's
that's
exciting. Yeah.
fantastic. Right? And then your juices start flowing. Then
Mhm.
sometimes you read something and you're like, wow. Then you go for a walk. You
Oh yeah.
think about it,
Think
come
about
back
it
and
and
say, that's great. And this is why, because this is my profession. Basically, this is how I make my living, and I have 30 years of experience full time,
yep.
and so I've seen a lot of things go like this, right?
Oh yeah. Yeah, I
And
can imagine. Yeah.
currently, what I think you guys bring to the table, because we gotten to the point, this in recent years, with a lot of these just new frameworks, new tools coming at you, and people
Mhm.
just spend so much time trying to learn these new tools, and there's no time for thinking, because you're always like,
Oh yeah.
right, and you
Yeah,
need to
exactly.
set some time aside to say, okay, and you had some thoughts about that, like go back to fundamentals, don't just get
Yeah.
stuck in learning every week, learn a new framework.
Yeah.
You're going in circle, right?
Exactly, you never get anywhere. Exactly, the language agnostic knowledge, the most important, in my opinion. I also made a tweet about it some months ago that I think that's the most important because, of course, the tools and the frameworks and they help us. Of course, they help us to be more productive and more efficient. But I don't know if what you learn today it will be deprecated by tomorrow, and basically you have to learn it again and again. And but if you learn really the fundamentals, really like the action programming and all the things, writing clean code is really a language agnostic. So I don't know more now. I think 1 week ago I was asked by a friend or a mate. He needed some help to produce clean code, and I needed to help in a language. I am not I'm not an expert. I also told him, yeah, I'm not an expert, but let's figure out. And I could help him a lot. I was also, yeah, more or less, I was impressed that I could help him a lot writing clean code in a language I really don't know. And I had confirmed the fact that really I think the most important is this kind of knowledge. But yeah, nowadays a lot of people jumps on the hype wagons, bandwagons, and they try to. Yeah, and it's understandable. I also like frameworks. Huh? I also use them on daily. But the most important is indeed the fundamentals, as you said.
Yeah, and just because you master the tool doesn't mean the job is done.
Yeah, absolutely. Yeah, exactly.
Because now, what you're gonna do with the tool?
Exactly how you use it.
Yeah,
So that's
like
also.
if you use the analogy from real life, if you go and buy all these like power tools for doing home renovation, and you know how to use them, all the
Yeah, exactly. Or
but then do you know how to really renovate your kitchen? Right.
exactly, absolutely. That's true. Or you buy a bat, huh? Like a squash bat or a baseball bat. It still doesn't mean that you can play a really good
Yeah,
baseball, huh? You
exactly.
really need to learn how to use it and apply it in the given context.
Exactly. So yeah, that's great. Now, one thing I wanted to ask you is what we are learning, like because when I started, this was back in 1990, so it's going to be 31 years in August. What we
Good one.
back then, what we kind of, we were thinking, okay, this is branch of engineering, right? Because there's some mathematics involved and some logic and whatnot.
Yep.
And we kind of had this mindset that this is the same as any other engineer. You just have, you have your blueprint.
Yep. Yep.
So you measure twice, cut once. So you wait on your blueprint, and to us, it was coming in the form of requirements.
Exactly.
Everything is, all the details are there.
Yep.
Over to you. And importantly, the blueprint was signed off.
Yeah.
It's called change management. So you freeze it, like, okay, this is it. No more changes. Over to you. You implement. You hit keyboard, you write code, blah, blah, blah. You're done. Freeze, code freeze. Over to testing.
Yeah.
Right. So that was kind of your classical, your traditional engineering.
Exactly.
But then, we came to the realization after many, many catastrophes and fiascos and failures where, you're doing everything properly, but then you realize there's so many defects and things are not really. Then we realized that, okay, maybe it's not, maybe you cannot map it back to traditional engineering. Maybe there's something different about software, right? So I think we started to discover that software deals with more uncertainty.
Yep, definitely.
If you're doing your traditional, let's say you're building a bridge or a building, then, there are some uncertainties, but not that many, right? Because, you can calculate how much concrete do you need to bear the, whatever. And it's quite certain. And engineers know how to do the calculation projections. Say, okay, we will need this much material, right?
I learned it, so that I mentioned the civil engineering. So I'm coming from this, so I know what you mean. Having the blueprints and
and so that's great, and it works.
Yep.
It works in many, even in hardware, in car industry. We know we're dealing with physical material. We can measure it. We know. In software, it turns out to be not so certain. Right? Because when you look at, I don't know if you saw this, there's a pyramid of uncertainty, or pyramid of certainty goes with that. At the top of at the apex is religion and metaphysics.
I know.
Where everything is uncertain.
True.
May have some
pretty much.
So we can never for certain know. And then as you go down, the uncertainty becomes a little bit more certain. So you have maybe economics. And you may have, I don't know, like philosophy, economics, psychology. It's also a lot of uncertainty. All the way down to hit the bottom is mathematics, where 2 + 2 certainly is equal 4, right? There is no uncertainty there.
Exactly,
And so engineering, so you have mathematics, the most certain, then you have physics, then you have chemistry, then you have engineering, and then above engineering is software with more uncertainty, right? Where you move into a project, you start building something, but right now you're quite mature engineer. You cannot really be certain, so that you can start. You have to try. You have to experiment.
Sure,
Right? And so this is basically what we are trying to cultivate now. Is this what we call skillful procrastination?
Okay.
You don't just rush in. You procrastinate. And that another side of the coin is called Yagni. You aren't going to need it. You heard of it.
Sure,
Right. So these are interesting things. And because if you're dealing with more like old school software developers, I find they sometimes don't get, they have difficulty accepting Yagni, right? Or procrastination. Because if you're working on a team and they're building something, there's a lot of these experienced guys who say, oh, I know, we're going to need this and that. And they start building something for the future because they know, oh, believe me, this is going to, and now they are being eager. So there's this eagerness. People rush in and say, and they build everything ahead of time, right? And then it ends up being waste because next week things change. And all of a sudden, this was waste of time, right?
Waste time and money,
And money, And also, it creates clutter. It creates bloat.
Yeah, exactly.
So one of the things I'm noticing over the years when I'm dealing and leading teams is it's very easy, and a lot of people slip into delivering bloat. So you're going to look
Yeah.
at the people work on something, you look at the repo, and it's very bloated. There's a lot of
Oh
things
yeah.
that is like fat. You don't need it. You can trim it, right?
Yeah, yeah,
But
exactly, exactly.
for some reason, people have difficulty getting rid of the code.
Hmm.
They was like, oh, no, no, don't delete that. Maybe I think I may need it later.
Yeah, yeah.
Right? You know
Absolutely.
that.
That's yeah, exactly. I also been there. Yeah, yeah. Oh, it's a really good, well-designed code, and I will need it later, and I will just leave it. But of course, in the past. So,
Yeah, yeah. And
but I,
that, yeah,
I absolutely agree with you that yeah, exactly like engineering something, a bridge or a building. You really have the blueprint, and after that you just follow the plan, and at the end it will be fine. But in software engineering also, if you follow the waterfall methodology over there, they do the same. The waterfall is basically the same. You have the blueprint, and after that you go through the different development phases, and then at the end you realize it's not what you wanted to build. Uh, so basically, yeah, I totally agree with this. And also that's why the agile methodologies and working in short cycles and verifying what we are building, that's where we should be heading. Basically, I would say we can compare software engineering a bit to the manufacturing a bit, like where we build a small piece and we verify, we test, and after that we build another small piece, we verify. And basically that's what's happening. And basically that's the way to go, the agile methodologies and working in short cycles, getting the feedback. Also high customer collaboration is very important. But issue is that it's still not good enough somehow. Or yeah, there are maybe multiple reasons for that. But if you see that, there are it's agile methodologies has been here, or they have been here for a long time or longer time. But still, there are a lot of disasters, canceled projects, and still a lot of people don't follow them, or either if they follow, they don't know what agile mindset is, or they confuse the term. They just do agile, but they are not agile. Yeah, I'm of the opinion that somehow this whole software engineering is still not mature enough. The whole industry, I would say, we are in a young shoes. For example, also regarding the testing, it's also very important. For example, we don't read testing as important as in other industries. For example, as you said, building a bridge. For example, you and me, we wouldn't go over the bridge if it wouldn't have been tested, right?
yeah,
Or let's say taking a medicine, we would never take a medicine if it was not tested. Or for example, how about driving a car? Over there also, we wouldn't drive a car if it would have not been safety tested. But somehow in software, if something was not tested, we just deploy it. And after that, yeah, we realize it is a bug or dysfunctions. After that, we fix it. Yeah, it can, maybe it has something to do with the fact, but sometimes it's not that critical. Of course, with self-driving cars and also the medical robots and all the things, of course, it's very critical. If they fail, I mean, the software fails, which operates these kind of, for example, robots, medical robots. But a lot of times, for example, when you have a website and over there, if you have a bug and, for example, the phone number it's not displayed correctly, then yeah, I would say nobody's going to die. But
yeah,
still, somehow we are not mature enough, and we don't treat testing very important. And I think that's one of the main problems. And also, as you see in Twitter, me and also other people, we try to kind of push this. The testing is one of the most important, and we really need to do it frequently. Because yeah, it is basically one of the most important. So I think the question is whether we're gonna get there or not. I don't know. We do our best. I mean, with Twitter is still just a small group of other developers around the world, but more and more people start using Twitter. So hopefully we can make a difference and we can make some transition to this mindset.
yeah, yeah. No,
That's one of my main goals, of course, and also yours,
sure.
yours as well, I would say.
Yeah, I mean, it's nice to see that you guys are taking this initiative, and because what we are predicting is going to happen,
Mhm.
and nobody has the crystal ball, of course, but
Oh yeah.
we are. It looks like we are slowly moving into the age that is called edge computing. You probably heard of that.
Yeah, yeah.
And with edge computing, um, basically we're talking about software that is governing the behavior of physical objects, right? The IoT, right?
Yeah, yeah.
And then it becomes a bit more risky to have defects and bugs, right?
Yeah, 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 exactly.
You mentioned self-driving cars. Basically, in the future, all the objects will be data centers, so you'll be decentralized, right?
Yeah, yeah, true, true.
Right. And so you cannot afford to have malfunctioning, and I mean,
yeah.
I mean, today, like you say, okay, you have you have built a web app, and maybe I can post a picture of my cat, and maybe the picture of my cat gets lost. So big deal. I cannot take it to the court.
Yeah.
You lost the picture of my cat, right?
Yeah.
It's not the end of the world.
Yeah.
But when software controls everything, right?
Yeah, exactly, exactly.
You
It's
now
getting more
need,
and more.
yeah, you now need real professionals to work
Yeah,
on.
yeah.
Not just somebody who finished a 6-week quick and
Yeah,
dirty
yeah,
course.
exactly.
Now I'm a software engineer. After 6 weeks, I go and I build. Whoa, not so fast.
Yeah, yeah, exactly, exactly.
Yeah, so we need to have this kind of strong core of influencers,
Okay.
people who like you'd be embarrassed to hear being criticized by these people, right?
Yeah, yeah, yeah.
Also be like, okay, we gotta grow up, like you say, we cannot continue to be in diapers. Get toilet trained, grow up, start seriously doing this. And
Yep.
like you said, testing is there's two things. One is testing, testability. Another thing, because I was doing some, there was a point in my career not that long ago where I decided to try and figure out why are so many software projects disasters. And either, you know, there's all these defects, or they're over budget and over time, or they never take off, right? And
Yep.
one thing comes to, seems to always point, emerges as a factor. And that thing is people go and split into teams. So you basically, you have a vision of the product,
Yep.
and you say, okay, over here, this team is doing API, this team is doing that. You know, you kind of divide and conquer, right?
Yeah, yeah.
And then people start working on building their side of the product.
Yep.
And time goes by and money gets spent. And then the time comes when they say, okay, now let's put it all together and test it. And then they realize that they don't fit together.
Yeah, yeah, yeah.
This is the main, in my opinion, this is the main reason that's causing all these things to be, or gives a bad reputation to our profession.
Oh, yeah. Exactly.
After spending so much money and having, excuse me, having all these experts on the team and paying them big bucks, and in the end, they cannot put it together.
True story.
Right?
Yeah.
You've probably experienced that.
Yeah, yeah. I also, yeah, I've been.
And it's not, you know, and it's not necessarily the fault of each an individual team. Maybe they did a perfect job. Maybe they really built this component absolutely fantastic. But what good is it if it cannot collaborate or cooperate with other components? If you cannot put the system together, right?
Yeah, yeah, that.
So, excuse me,
Yep.
to fix that, what we need to do is what we call accuracy before precision. So
Okay,
first,
never heard of.
So in my discipline, the first thing we want to do is we want to integrate. Okay. Before we start, excuse me, something's in my throat.
Sure. If you want, you can get a voter or just take your time.
So we need to, you need to have approximation first. It's like, you know, when you go to IKEA, you buy furniture, then you bring it home. What do? First thing you do, you lay all the parts on the floor and you count them.
Yeah.
Right?
Been there.
You don't start, you don't just grab the first thing you grab and you start screwing, right?
Yeah, exactly.
Because you may be doing a good job, but then later on you may realize, oh, we are missing this part, or I did it wrong.
Yeah.
Right? So this approximation is very important. Before we start, precision work would be TDD, right? TDD is like, you know, you explained this today, where TDD, what it is, it's actually a blueprint, right, of a smaller, tiny little thing. It's perfect, you hone it, you refactor it, is good, right?
Verify.
But you do it after you actually do the approximation work. So first it's like approximately you put, so what do we need here? All these things are approximate. They are very, they're drawn in very like, what's the word? First draft, just like very crude outline. Like, okay, we need this here, this there, and then you integrate. But you have to integrate in executable form, not just integrate on paper.
Oh yeah, true. Yeah.
Right.
So it doesn't compile, huh?
Yeah. So our approach is to have this kind of executable system that is, you can run it at any point in time. And in the early days, in the first phase, you are basically faking everything. Everything is simulated.
Yeah.
Things don't exist, but you pretend they're there, right? And you just you bring the system up, and it's talking to all these components, and they're all fakes. They are all virtual, right?
Yeah.
Then little by little, you put in the real code.
Yeah, the replace.
And
Yeah.
Each time each time you put the real code, you test everything again to make sure nothing got broken. Now that gives you a better chance, or lowers the uncertainty, that once you're done, all these things will be talking to each other and everything will be hanging together, right?
Yeah, exactly.
And the reason I'm mentioning this is because I find huge resistance when I'm teaching teams, when I introduce that. For some reason, people disagree. People want to have the concrete, real thing that can be touched before they try to integrate. But by that time, it may already be too late, and you have already spent, because if you're doing approximation, you're doing service virtualization.
Yep.
It should be very easy, brain dead easy. It should be declarative.
Yeah.
I remember I talked to you about this product, Mountebank.
Yeah, exactly. Yeah. I haven't checked.
And
but that's service.
This is JSON. You can whip up all kinds of services in a matter of minutes. You just create a little JSON. You just tell it what. And now this guy is sitting on a network, maybe in your local host or somewhere, and it's pretending to be the real thing. So it's helping you quickly integrate, especially if it's running in your locally in your memory. The integration tests are sub-second. Right?
Okay.
But anytime I make change, I'm running it, and I always convince him that it's still up and running, still working, still. Yep. Ron Jeffries said that the trick is never to let code not be working. The code must always. You should never leave like few hours just coding and don't even check, right? And so I think that discipline is very hard to teach to either novices or to people who are already hardened in some other mindset. My experience, that's the biggest challenge. People are always like, no, I disagree. I don't like this.
Oh yeah.
Stuff like that.
Yeah, it requires a mind shift. Huh? You really need to change your mind with this. Also, as you said, that we have to make keep the system working. That's where TDD also helps a lot, because we see our code every minute working. We get a continuous positive reinforcement about the state of the code, what we are building, and basically that's the way we should go, and that's the best practices around this.
Yeah, and another thing that's very hard for people to agree on is that the prime focus when you're coding should be to keep that green bar as much as you can.
You mean the green bar here? You mean the tests, or what do you mean here, green bar?
The green bar, we call the green bar when you make a change, you run your tests, and all the tests pass. They go like.
Yeah, you're right. Yeah, absolutely. Yep.
So it's more important to keep this bar green than to write clean code. You can clean it up later on with refactoring.
Yeah, sure. Yep.
But the first initiative, anytime you make a code, you have to make it green. And Kent calls it fake it till you make it. So it means hard coding, doesn't matter. But the important thing is you keep inching by always seeing your system is in green. That's your main focus, right?
Yeah, exactly.
And whenever I teach that, people are like, wow, this is stupid, blah, blah, right? Some people tell me this is the stupidest thing they've ever heard.
Yeah. It's
and these are experienced developers. They are really good coders.
Yeah, exactly. Yeah, I admit. Yeah. I also met with such people.
Yeah, they may be much better coders than I am. And some of them are amazing, but just they don't buy into this discipline.
exactly. I also, as I said, I also met with these kind of people. I mean, they were really amazing developers, but somehow when I told them, okay, let's write clean code or follow the test-driven development, somehow they were too conservative to do that, and they said, sorry, we are not going to do that. Also, we had some discussions with the tech lead, and half of the team wanted to apply the TDD. Other half said, sorry, we are not going to do TDD. I can write also clean code, and I can test afterwards. And after that, at the end, we concluded, okay, half of the team will use TDD, half of them not. We are making a mistake here. We told them, but yeah, we cannot convince everybody to use that. The issue is here, I think, that software engineering is it's not about techniques and tools. It's also about, it's a people process. Huh? I mean, of course, we write code and we talk with machine, or we write something which talks with machines. But at the end, we work with people. We have to convince the managers. We have to talk with the customers. We have to get the information from the customer, the requirements, the specification, all the things. It involves a lot of people. And yeah, I mean, that's the most important. I would say also they said, the Kanban. I don't think that there are problems with Kanban or Scrum, even Scrum. I don't think there are problems with that. There are problems with people. Maybe it sounds a bit harsh, and also I'm also not perfect, and sometimes I am the one who has problems. But somehow, yeah, we have to deal with people, and dealing with people, it's very important, not only in software engineering, in everywhere, basically. Of course, we can have hard times. Also, nowadays, we have this Corona and all the things, everybody's under some pressure, everybody stays at home, a bit depressive. So, of course, we know the best practices, but we need to use it. We need to use it efficient way, and it's not the easiest because yeah, there are people also, not only machine and software.
Yeah, definitely. But excuse me, this brings another topic, which is, in my experience, to do TDD properly, which we want to do because of the testability. Yep. The mindset that needs to change is towards being eager to do rework. And
yeah, exactly.
We're finding a lot of people have big problems agreeing with rework. People think, look, you're a professional, you have a lot of experience, you're charging top dollars, and you worked on something, and now you're telling me you're going to go back and work on it again? Like, I don't want to pay you. I already paid you to work this. So rework is considered unprofessional.
Yep.
But it is a vital component of our profession. And so exactly. It's a very tricky thing to explain to whoever is your customer, your manager, your supervisor, whoever's paying your bills, right?
Yep.
Unlike, if I build you a bench, yep, and sell it to you, and you sit on it, and I come to your house like, okay, I need to charge more, I need to do some rework. You will be like, oh wow. Why? I thought you're a carpenter. Exactly. Why do you? I did. It can collapse because I didn't. Well, I'm not paying you for that, right? Exactly. So that mindset now applied to software, people are pushing back. People are saying, no rework.
No rework.
Means no refactor. They don't like refactoring. They're like, okay, you're given one chance, do it properly and move on.
Yeah, exactly.
Big problem.
It's not the way. Yeah, exactly.
And yeah, go ahead.
I mean, yeah, it's difficult to manage the complexity. I mean, with this, for example, as you know, we have a plan, you follow it, and after that you have some issues, and after that you have to the rework what really works. And with the managing complexity, I mean, it's much. I mean, I would say software engineering is very difficult. It's not difficult if you go in a small and baby steps, because after that you get the verification and all is fine. But if you really take big steps, then you will have hard problems. You will have to redo it and all the things which a lot of companies are following it.
But again, while you can maybe make this transition and convince them that let's go in small steps.
Yeah.
That's still not enough because the way they understand small steps is incremental.
Yeah.
The way we understand small steps is iterative.
Yeah.
Revisiting, and that is.
Yeah, that's.
They're saying, okay, you go in small steps, but each step is adding new thing. No.
Yeah.
I'm revisiting. Right?
True.
And that is very hard to sell at this point. Maybe there will come a time where this becomes a normal thing that mind shared, everybody understands. But at this point, it's novelty, at least what I'm working with.
Yeah.
They don't understand, why would you have to go and work on it again? I'm okay
Yeah,
with
exactly.
building tiny little new thing. That's great. That adds value. I don't see any value in you refactor, like because it's not changing any functionality. Why am I paying for this? Right?
Yeah, exactly.
So that's something that you need to start selling, I believe, also on your projects, right? To somehow convince them that this is vitally important. And you or somebody mentioned technical debt, I think, today.
I think it was not. It was Jan maybe.
Yeah, somebody
I
mentioned
don't.
technical debt.
I think no. It was Nick created a tweet, and after it, Maxi wanted to create. He wants to create article, and he posted a tweet about, okay, give me some thoughts for food, but I was not involved in the talk.
So people just wanna and software is still a very mystified discipline, because unlike physical objects where you can see them and you understand, you see Empire State Building, you can understand, yeah, it cannot be built overnight.
Yeah, exactly. Yeah.
But software, you see just the screen, you see a few buttons, you're like, hey, how come this is taking 6 months?
Yeah, it's intangible, huh? Like we cannot grab it, we cannot have it in our hands. Yeah, of course, if we have an application on the telephone, we have it in our hands, but we have the device. So that's why it's intangible, and that's why it's difficult. That's why it's difficult to handle it and to think about it, and that's why I think also it's one of the reasons that testing is not taken seriously, because we don't know how we should handle it. It's not a bridge. It's not like, okay, I'm going to walk over. It's like, okay, what is it? It's a software. Okay, if you have some implication, something will be displayed wrongly. So yeah, exactly. That's interesting thing. But the question is how could we, I would say also, like as a continuous improvement or being agile, how could we improve this? How could we make the world a better place? Because I mean, we have been all of us, or a lot of people have been kind of advocating best of engineering practices, and we do our best, but it's somehow still not enough. And I think some weeks ago you mentioned this, that code as a text is not the best. It's not the best way to produce software. I was a bit. How to express myself. I was like. Yeah, it was an exciting thought, I would say. What you said, that code as a text is not the best way, but the issue is, maybe, of course, I want to hear your opinion about this. What do you think about this code as a text? Because that's what you mentioned, that we cannot go that far with this code as a text, because what we can see right now, it's the whole ecosystem is too big, I would say. The whole software engineering ecosystem, we have too many frameworks, we have too many languages, and somehow we don't have some kind of standardizations of the languages. Of course, they say that, yeah, choose the language based on the domain. Choose, I don't know, C++ for embedded device, or JavaScript for front end, and C# for backend. But if you see, it's basically not the case. I mean, for backend, really, I can do backend. We can do backend for multiple kind of languages. You can do backend with JavaScript, with C#, Java, Go, etc., many other languages. So it's kind of, the ecosystem is too big, that we start being unable to handle this. So that's why we have a lot of issues, because and also going back to the beginning, where you said that basically maybe this is the problem, that we are focusing too much on the tools and frameworks and all the things, and we forgot that the most important task is to make the customer happy, to deliver value, and to basically to make working software. And with this, of course, they help. I mean, all the technologies, like also like Kubernetes, it's really good for scaling. And I'm also impressed the whole Kubernetes ecosystem, but it's kind of over engineering most of the time, of course. And basically they still won't make the customer happy itself. Of course, they provide better non-functional requirements. I mean, scalability and availability and other things, but still, making the customer happy. That's the most important, I would say.
Yeah. So the way I see it is, if we compare software and the evolution, or whatever you want to call it, it really hasn't relative to, for example, improvements in hardware, just computing hardware and other engineering branches, software is very stale. It hasn't made any breakthroughs in 50 years or more. So we keep going in circles, like you say, reinventing the wheel. People package and sell you something as novelty that you go back and you read like, wait a minute, this was has been all done before. True. Exactly. Why are we reinventing the wheel? But anyway, that's part of this ecosystem, part of the economic model, and that's how people make their fortunes and blah, blah, blah. But it's kind of shameful and embarrassing that such big pool of talented engineers and some of them geniuses haven't made any breakthrough in 50 years. That's like, to me, that's appalling. I can't believe.
Yeah, true.
And I blame code as text. I think code as text is the main culprit why we are stuck in this. Chasing our own tail. Like you say, millions of frameworks, millions of languages. Basically, what? What have we accomplished? Nothing.
Yeah, exactly.
Another thing is, if you look at human evolution, there was one point in human history when the printing press was invented by Gutenberg, which was a very decisive point because it enabled probably everything we have today was enabled by the ability to propagate text, right? Symbol.
Yep. Symbol,
yeah. And it made a huge impact on civilization, on the entire planet.
True.
Everything, industrial, Renaissance and the Age of Enlightenment, Industrial Revolution, Information Revolution, everything is based on symbols being propagated into the masses via printing press. And today, printing press is replaced by the web, the internet. Internet is basically a giant copy machine. It just makes endless copies and broadcasting and pushing, right? Okay, so that's fantastic, right? But when you step back and think about it, what is printing press? It is nothing but a bunch of symbols put on a two-dimensional flat surface. That's all it is. And this now shapes our entire lives. So our lives are based on, today, you and I, rectangular flat surface, glassy surface. This is our life. Has some symbols, has some pictures of cats and pictures of people, etc., and emojis. And if you think about it, this is very debilitating. You are sacrificing so much of your incredible faculties because we learn, we create not just through eyes and symbols on the flat surface. We are spatial beings. We operate in space, three-dimensional space. We see, we hear, we smell, we taste, we touch. All these things have been abandoned. When you think about before software, how did engineers work? They were making those maquettes, those little replicas. You're simulating. So you make a physical three-dimensional object, either by reducing the size. Like, for example, if you're building a bridge, you have a model of the bridge that's size, or by enlarging. In chemistry, you enlarge molecules, right? But these are all things you can walk around. You and I can give it to you, you can examine it, you give it back to me. This is what's lacking from our profession now. We are not doing anything in space. We're not doing anything engaging our entire being. Because, this famous physicist, what's his name? Feynman, the nuclear physicist, just genius.
Which one?
Richard Feynman, I think.
Okay.
Anyway, the guy real genius. And so I think they were writing a biography about his work. And somebody who used to work with him in the same office, they said, to watch Richard Feynman think and create something was a remarkable experience. He was contorting his body. So it takes the entire being to be creative. Not just flat rectangular surface, right?
Yeah, I see your point.
You have to be immersed in your surroundings. And that's where I think we failed, that we just reduce ourselves just to flat surface and text.
Yes, exactly.
It's really debilitating. You're selling yourself short. So many of your other capabilities have been shoved to the side and now you're looking at some lines of code, which is, that's not how it should be. I think we need to make a breakthrough, get out of that prison, and start creating an environment where we can be more innovative, creative, and really spread your wings and fly.
Yeah. Okay.
This
I like
getting stuck with some code and some patterns, that's Mickey Mouse stuff. That's just like pathetic, right?
Yeah.
And so that's why I'm looking at you guys, you young generation. You need to make a breakthrough. You need to get out of this straitjacket.
Okay.
Because how did it come to be? It came to be through economic pressures. Back in the 60s, computers were phenomenally expensive. Only like military government could have it, right? It's just millions of dollars. Then in 1974, Intel created the first, silicon
chip or
CPU, central processing. Before that, we had PUs, processing units, and we had mass computing back in the 60s. I don't know if you read about
it. Yeah, but it's a long time.
Yeah. So it's just network of processing units. There was no, it was decentralized. And it was a phenomenal model, but it was prohibitively expensive, right? Intel democratized computing through the Intel chip. Okay. And our entire way of thinking about computers got shoehorned into this central processing unit. You're like drinking from a straw, right? There's no parallelization. It's one thing at a time. And that's how we were trained to think. This is shameful now because we don't have to. And the Moore's law, but every 18 months, the speed doubles. So it creates complacency. Like, okay, my program is slow. And instead of me trying to make it better, I just wait 18 months and it becomes twice as fast.
Yeah.
So that's lazy. So now I think these days are over because I read that Moore's law has hit the ceiling. You physically you cannot keep doubling, right? So now what are we doing? We are branching into parallel, multi-core.
Multi-core,
right? And doing imperative programming with shared mutable state on multi-core is just suicidal. Because they say
shared state always, huh?
Yeah. They say if you compare regular programmers to electricians, so like somebody's electrician, they know how to do the electrical wiring. The parallel now, if we want to do a parallel programming, should be compared to bomb disposal experts. So you go you learn how to dispose explosive device. Right?
Yeah, it sounds like a
completely different discipline.
Crazy.
And we don't have that in our community, right? With that kind of expertise. We're not talking about it, right? We're still talking about drinking from a straw and one thing at a time, imperative.
Yeah. True story.
That's not where we want to go.
And how could we improve that? So that was also the question, that maybe the virtual reality or augmented reality, or what could help us? What do you think? Because right now I cannot think of anything which should really help. I don't virtual reality, but I don't know. What do you think?
I think edge computing and IoT.
IoT, yeah, okay.
And basically enabling, because the technology, we do have the technology, and like I said, hardware is phenomenally progressing. We now have, for example, I don't know if you've heard of the Internet of Animals.
Internet of Animals?
Internet of Animals. And I think it's being pioneered and spearheaded in Germany mostly.
Okay.
We now have the technology where we can have such tiny cameras with a lot of, the capability to send, I don't know, I don't know the details technical, but they implant tiny little cameras into beaks of birds, into animals, and then they collect copious, huge amount of data.
Wow.
In the wild.
Wow. I like it.
Everything is recorded. Because let's be honest, we actually know very little about animals. We have few guys go out in wilderness with camera. Right? What you need is like a lot of information. And then you do big data, you do machine learning and all that, crunch it down. And now you can start learning a little bit more about these animals. What do they actually do? How do they live? Because we don't know, right?
Exactly. Maybe we could learn from them, huh?
Yeah, learn from them. Yeah. Many engineering inventions came by imitating or modeling nature.
Replicating, the nature, absolutely.
And so what I'm trying to say is we are entering the age where a lot of inanimate objects or man-made objects will be endowed will be data centers.
Okay.
And they can be programmable, right? So you can envision with mini drones and stuff, I can conjure up an object in space that you and I can discuss.
Okay.
So it may float up in front of me and you, and it's a real, it's not hologram, it's a real object where we can like moving, programmatically moving pieces and reasoning about this. And now we have a completely different understanding of the system. Right now, it's all in our head. It's abstract. It's like you and I can talk about some software model, but God knows my understanding, your understanding. We think we agree, but maybe we don't.
Sure,
And later on, we say, oh, sorry, Danny, I totally misunderstood you. Right? But it's much better if we're talking, if we use all our faculties, like facial, right? You walk around, you touch, right?
All the senses,
You push, you know, and that's how I can present my cause. Because right now, we live in a world where we are trained to trust authorities. So if somebody comes and says, Alex, this is a good thing for you, and blah, 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 and I have no evidence, and we were trained to suppress our need to like, show me the evidence. You're like, no. The authority says, I believe. I don't need evidence. That's bullshit. I'm not buying it. As a human being, I need evidence of everything. Show me.
Show me.
Convince me. Just because you come with a title and you're Mr. President, I don't believe you.
Yeah, true.
But, you know, we've been brainwashed to say, no, you have to. This is Mr. President. Your well-being is the foremost on his mind. That's a big fat lie, we know. So we need to move into the world where wherever anybody's presenting to you, proposing, you got to be convinced. Show me the concrete evidence. Because right now everything is on this like flat piece of paper with somebody signed. That's bullshit. We know that. That's made up.
There comes two questions with this. First of all, would it be sufficient enough to solve all of your problems? I mean, this edge computing, or maybe this solution, or with this infrastructure, what you are envisioned. Secondly, how shall we set up this infrastructure? I mean, this whole thing. I mean, we need to really code them. Somehow we need to build it. I mean, they say that in the future we don't need, but there won't be need for software engineers because there will be AI who are building the websites and everything. But also those AIs has to be built, and also relating to this topic, this infrastructure has to be built by engineers. So the question is, of course, it's just you don't need to give the specific answers. It's just thought for food that how could we set it up without code?
I know. That's really good. I don't think it's going to solve everything, of course, no. And it's going to create new problems that never existed before, right? But that's human predicament. That's human condition. That's how it is. And definitely we should not stop because of that, knowing that there's no definite solution. But anyway, we keep going. It may improve a lot of things. As far as how it's going to happen is, I don't know if you read about how internet came to be, how a World Wide Web came into being.
Not specifically, no.
Okay, so back in the 80s, so TCP has been in the 60s has been built for the military purposes as a decentralized, so that it can withstand nuclear catastrophe, right? And then as people started getting, as computing became more and more affordable and started trickling into offices and homes, sometime in the 80s, it became apparent that pretty soon, everybody will have a computer. And so just having a box in your house is kind of not enough. They should be connected. And so how should they be connected? And there was a big project, I think you will enjoy reading about it, in the 80s, called Project Xanadu, Project Xanadu.
Okay.
And this was the first iteration of the web, where they envisioned all computers connected through TCP.
Yeah, sure.
And then what we have today, just worldwide network that machines can talk to each other. It failed miserably, and the reason was there was a hard axiom built into this model that says disallowing broken links. It says it was a gargantuan modeling effort. How do we make sure there are no broken links? and it just kind of it became bloated and kind of collapsed under its own weight because the solution was so over-engineered. It was so
Okay.
intricate. It never took off the ground.
Okay.
1991, Tim Berners-Lee basically said, "I don't care about broken links. Not my problem."
Yeah.
The World Wide Web. And so what?
Okay.
Okay, you click on a link, it's broken. So what? Who cares?
404, huh?
See, it will take somebody like him in the future to figure out how.
Yeah.
We cannot, because if you try to create this perfect engineering world like Xanadu, it doesn't. It has to be quick and dirty. It has to be, kind of Unix philosophy. Worse is better, and where I don't know how to explain it, but you leave it to people to figure it out. You cannot prescribe it top down. Say, okay, this is how it should.
Yeah.
But one way or another, once you have enough of a critical mass, you have enough sufficiently mature technology and many, many man-made objects who are already data centers and can communicate via 5G or whatever, you have fertile ground for some genius to step in and figure it out. And then before you know it, everybody's doing it, right?
Yep. Exciting.
But again, I think it all boils down, same as with the internet, boils down to critical mass. We had to reach the point where we had enough computers in offices and homes that we start thinking, oh, wow, we have to put them together. So once we get enough of these objects, IoT, who are endowed with processing power and 5G and all whatnot, that we can start saying, okay, so how do we put them together, right? How do we make them work for us? Because now you're talking about programmable workforce, but you can. Right now we have the web is now programmable content, right?
Yeah.
We need programmable workforce.
Maybe it comes to the play, nowadays it's really also really hyped the thingy, the blockchain, that they want to store everything there, and over there you can run a smart contracts, and they want to store everything. And if every information is there, you will never get the 404 because you can always find them back. It's also kind of it's web 3.0, right? That's what they are trying to envision. Of course, we are still in early days in that, but basically it also wants to solve this problem as well.
Yeah, definitely. Something will emerge, right? Something.
Yeah.
I mean, none of us, at least not me, could have predicted blockchain.
Yeah.
And then once I read about it, I go, wow, okay, this makes sense. But before that, I had no idea, right?
Yeah, sure.
So, okay. Thank you, Danny. This was fantastic. I really
absolutely. Yeah. I really enjoyed it. Thank you very much for inviting.
I don't want to keep you any longer, but I really appreciate you coming out of cold, like just taking my offer. And this is going to be useful, hopefully, to some people.
Hope so. Yeah.
Coming from, and I'm sure if somebody reaches out to you for help, you will be glad to help them.
Absolutely, more than happy. Really, thank you very much for inviting, and it's been a pleasure to be here and also getting to know you. And I would say let's keep in touch and let's escalate these topics, and let's see where we can.
Yeah, how are you enjoying Vienna? You've moved recently.
Right now, I'm in Hungary. Because of because of these Corona times and Christmas time, so I went back to my hometown, to my family, and but I like Vienna pretty much. So I moved there in July, this summer, and I love it. It's a good place. It's one of the most livable city worldwide. So I like it pretty much. I also get a new apartment.
Not far from your place.
Yeah, it's 5 hours, or with car 4 hours. So it's pretty reachable. And in the back, even in the past, I used to live in Netherlands, and that from there it took 18 or 20 hours to get home by car, for example. Of course, by plane maybe. It's
better.
How
did you like it over there?
You mean Netherlands or Vienna? No, I loved it. It's a great place. Netherlands is really good, and also they are really advanced. Also in software engineering, and I worked with great professionals also for Philips and other companies. And I liked being there and living there. It was really good 4 years of my life. And what I wanted to be closer to my family and my other friends. So that's why I decided to go to Vienna, because it's closer. I can come home anytime I want. So it's reasonable.
You were in Amsterdam or?
No, in area of Eindhoven, I would say
Okay. Oh,
Eindhoven.
okay.
Eindhoven, but yeah, Amsterdam was 1 hour. Amsterdam was 1.5 hours. Rotterdam was 1 hour. So it was, Netherlands is a pretty small country, and by car you can get from to the end easily in no time. So that's
Yeah.
why. So that's I visited these places many times. I liked it. It's a really good
Excellent. Great.
country. Have you been there?
Yeah. Yeah.
Okay,
I've been
cool,
to
cool, cool.
Vienna. Yeah. It's a good place, nice place. And I
Yeah,
guess
yeah.
because you're not, you are originally from Hungary, you don't ski.
Actually, I ski. In the last some years, I didn't ski, but since I was 6, I skied a lot with my family. So actually, I use Bigfoot. You know that the Carvalino Bigfoot is like this long stuff. It's not that
Yeah.
long ski; it's a small one. That's what I do. Also, my parents they are with my father and my brother. They are doing snowboards. So we did it until 22. I did kind of 3 times per year, kind of maybe even more. But lately, yeah, less time, rarely I would say. So also
That's
this year,
because Austria is
I,
good country for skiing, right?
sorry. Austria, yeah, it's
Austria,
really good. Yeah, absolutely. Yeah, exactly. Really good one. But also Slovakia, Slovenia, and basically around Hungary, you can,
yeah.
yeah, around Hungary you can find a lot of great places. So yeah, I'm skiing, but lately I ski much less. I have to admit.
All right, Danny. Pleasure to
Okay.
chat, and
Yeah, it's a pleasure. I wish you a great weekend further, and yeah, keep in touch.
keep in touch. Okay, have a good
Yeah,
day.
absolutely. Have a
Cheers.
good day. Bye bye.
Bye bye.
Cheers. Bye bye.